Okay, let's say we place the 1 kg object 1 meter from the center, from the point or from the equilibrium point. Okay. From here, if I place the 0.5 Newton of the load 1 meter away, is it the resultant moment force is equal to how much? Okay, so let's say so from here, there will be a resultant moment of force, resultant torque, that is 4.9 Newton meter. Okay, ladies and gentlemen, before we go through the question. That means that I want to show you another concept of the, okay, a simple example, some of the example of torque. So let me share the screen. Okay.
Introduction to Talk 1. We have learned that a force causes translational motion. A force can also produce a turning effect known as torque. For example, when a person closes a door, it is easy for him to do so by applying a force on the handle. The door rotates about an axis passing through the hinges. If he applies the same force near the hinges, it is difficult for him to close the door. In this lesson, you will be able to define torque and derive tau equals R times F. Derive tau equals I alpha. Deduce the analogy between the equation tau equals I alpha and F equals ma.
Ladies and gentlemen, this is the old version of the software, old syllabus software. So this means that previous syllabus include the torque equal to I alpha. But now we just learn the torque equal to RF only. We just focus to torque equal to RF only.
Click the play button and observe a person closing a door. The door undergoes a rotational motion. The turning effect of the force about an axis is known as moment of force or torque. The force F applied at the handle is perpendicular to the radial vector r. Here, the turning effect of the force about an axis can be defined as tau equals Rf. If F is not perpendicular to r, but making an angle theta with r, then, using the perpendicular component F sine theta, the turning effect of the force or the torque is given by tau equals Rf sine theta. In the vector form, tau equals r cross F. Click the play button and observe the hatch door in a ship being opened by turning the wheel. The wheel is turned by two equal forces acting in opposite directions. This rotates the wheel. Two equal and opposite forces shown is called a couple. Does the couple exert a net force on the wheel? No, the couple does not exert a net force on the wheel, even though it exerts a torque. The moment of a couple is the product of one of the forces F and the perpendicular distance d between their lines of action. The moment of the couple equals Fd.
So ladies and gentlemen, although in the circular motion, when we're turning something with F, both of the F are in opposite direction. But we said that these are the couple of force. Hey, what's mean by couple? Couple means that kekasih, right? Okay, a man and a girl, right? So the man chase the girl, the girl chase the man. So you see, this F produce a turning effect. This F move, okay, the direction, actually the top to the other side, this one to the other side, okay? Each of them are related to each other and each of them are always in couple. So in this case, actually we turn with a F. These two, although they are in opposite direction, we cannot say that the FD R times F, that means FD in other direction, we cancel each other. Although they are in opposite direction, but this opposite direction will cause the wheels or cause the steering to turn in circular motion. If the force act in opposite in the same direction, the couple of force in same direction, this will cause the wheels stationary.
Summary. The turning effect of a force about an axis is known as the moment of force or torque. Tau equals R cross F. Two equal and opposite forces whose lines of action are not collinear forms a couple. A couple does not exert a net force on an object, even though it exerts a torque. The moment of a couple is the product of one of the forces F and the perpendicular distance d between their lines of action. The moment of the couple equals Fd.
If the moment of a couple means that the forces, two forces, although in opposite direction, but both of them still related to each other to make the wheels to turn in circular motion. So we can say that the couple, the moment of couple or torque of the couple with the words couple is equal to Fd. But here we just use, okay, for ours, okay, system, we just use the torque equal to R times with the F, where the R and F must be perpendicular to each other. R and F must be in 90 degrees to each other. Let's go back to the slide. The turning effect, okay, the turning effect, that means that now there will be a resultant of torque. Resultant of torque means that here at this side, at the left side, if I put 1 meter at the left side, it produce a torque and cause this object to rotate with 4.9 Newton meter. Because the torque is equal to R times with the F, right? So this means torque, the unit will be Newton times with meter. Okay, so the unit will be in Newton meter. Now let's reset and we try to adjust again. If this is 1 meter, I put at 2 meter. So what will be the torque? The moment of force or the torque is equal to 0 Newton meter.
What is the resultant moment of force when the seesaw is in equilibrium? Click Answer.
So that means that just now answer.
The resultant moment of force is 0 Newton meter. Therefore, when a rigid body is in static equilibrium, the resultant torque is 0. Observe the person holding the car steering wheel at positions A and B. Click the play button. Observe the steering wheel rotating in the clockwise direction due to the forces of magnitude F acting at A and B. The two forces acting at A and B are equal and opposite to each other. This constitutes a couple. The forces are not acting at the same point. The effect of the couple is to rotate the steering wheel in the clockwise direction. O is any point on a line which is perpendicular to both the forces. The torque about O can be calculated as shown. Torque about O equals F times OA plus F times OB, which equals F times OA plus OB, which equals F times AB. Torque produced by a couple equals one of the forces times perpendicular distance between the two forces and is independent of the position of the point O.
So you see, just now we said that the couple of force F torque is equal to FD. So this means that here we just need one of the forces enough because both of the forces are equal magnitude, just the direction are opposite. Although they are in opposite direction, but these forces are not at in the same point. So this means that these forces will produce the effect of rotation. So this means that we said that this is the couple of torque.
What is the resultant force acting on the steering wheel by the couple? The resultant force equals F minus F, which equals 0 Newton.
So now we notice that both of them are in opposite direction, right? So we said that the resultant force is in 0 Newton, but the resultant torque is not in 0 Newton.
Conclusion. The resultant force produced by a couple is 0. A couple produces a torque on a body and causes the body to rotate.
Okay, the resultant force produced by a couple is equal to 0, and a couple produce a torque on a body and cause the body to rotate. Okay, resultant force is 0 because one up, one down. But for the couple is F times with the D not from the center, but the D is between the two F.
Summary. The torque or moment of force is the effect of a force to rotate a body about an axis. Torque is given by the vector product of the position vector of the point of action of the force relative to the axis and the force applied. Tau equals R times F. Magnitude of tau equals Fr sine theta. Two equal and opposite forces not acting on the same point of a rigid body constitute a couple. The resultant force produced by a couple is 0. Torque produced by a couple is equal to the product of one of the forces and the perpendicular distance between the two forces. The effect of a couple is to rotate a body, but produces no translational motion. Click the play button to observe the action of various coplanar forces on the rigid body shown. The first condition for equilibrium of a rigid body is the resultant force is 0. Click the play button to observe the resultant force.
Okay, class, look at here. And a rigid body, that means an object with 4 forces which lie on the same plane, yeah. Okay, so in BM we said that bersandar. pada satu sata yang sama. So this means on the same plane. So with different direction, various direction, no matter how, we need to know where is the equilibrium point, the center. So the center, let's say this is a center. So F2 with a distance of R2, F3 with a distance of R3, where F4 with the distance of R4, and the F1 with the distance of R1. All of the F magnitude of the F can be various, can be same, but normally difference. Okay, and the direction sure various, and the R also can be different as well. How
From
to
the
solve it?
diagram, summation of F equals F1 plus F2 plus F3 plus F4 equals 0. The second condition for equilibrium of a rigid body is the algebraic sum of the moments of forces about any point is 0. That is, summation of tau equals F1 R1 plus negative F2 R2 plus F3 R3 plus negative F4 R4 equals 0.
Okay, now let's say we assume that this system rotates in clockwise direction. Let's say, we assume that this system rotate in this direction, right? If rotate in this direction is positive, because why I said a positive? Because if like that, that means the F1 direction is in this direction and the F3 in this direction, right? That means that if they are in this in the direction to make the system to continue rotate with the same direction, that means that we can set that the top one plus with the top three are in the same direction. Okay, now if the top in the F2 and F4, what happened to the F2 and F4? Now we notice that F2 are in this direction, F4 in this direction. That means that F2 and F4 form a direction like that, right? So F4, this will be the F4 direction, and this will be the F2 direction. So the top, we can set that the top and top for 2 and for 4, they are in the same top. That means top 2 plus with top 4. But when the total of the top, okay, top, okay, total, okay, let's say total for the left side, it will be equal to the total top for the red color. The green color, the total green color equal to the total of the red color. So that means that it will be total. If this system are in equilibrium. So that means that you see, if I solve it, this will be like that. So is it the top one plus top 3 equal to the green color, which is top 2 plus top 4. From here, we notice that this will be negative, right? This will be negative top 2. This will be negative top 4. So negative top 2 and negative top 4. If I move to the other side, is it balanced? Negative become positive, negative become positive the other side. And F1, R1, F3, R3 will be remain at the left side. So as a result, if the object in equilibrium, that means that we can write either moment, that means that total of the top in clockwise direction minus total of the torque in anti-clockwise direction will be equal to 0 if the system in equilibrium. If the system is not in equilibrium, depends on which one is bigger. Okay, if the F1, F3, the product of the the total of the F1, F3 is if the total of the F1, F3 greater than F2, S4, that means that it will be in the direction of the F1 and F3. Okay. Let's move on to the next slide.
A rigid body is in equilibrium if the resultant force acting on it is 0 and the algebraic sum of the moments of forces about any point is 0. Summation of F equals 0. Summation of tau equals 0.
So if a system is in equilibrium, the total of the vector of force is equal to 0, same as the total of the torque will be equal to 0 Newton meter.
The picture shows a trailer weighing 30 kN joined to a cab at the point X. If the trailer carries a load of 20 kN, can you calculate the upward force F of the cab on the trailer at the point X?
So look at the diagram. The diagram shows a trailer weighing 30 kilonewton. Okay, the trailer, okay, with 30 kilonewton, joined to a cab at the point X. Join at the cab at point X. If the trailer carry a load of 20 kilonewton, the load is 20 kilonewton. That means total together will be 30 and 20 kilonewton, but the position of the weight are in different position. Where the 30 kilonewton is the weight for the lorry or the trailer. So that means that it will be at the center of the trailer. And this 20 kilonewton is the load, the weight of the load. That means that the forces, the weight on the load will be at the center of the load only at the center of the load. Okay, so now, okay, can you calculate the upward force F of the cab on the trailer at the point X? So we want to find the F. Okay, the joint here will experience a force upward because the weight, everything will pulling down, right? So in opposite direction. And for this point, we have the normal reaction force. So depends on which they want us to calculate.
In order to calculate the upward force F, the free body diagram should be drawn as shown. According to the condition of the equilibrium of a rigid body, the algebraic sum of the moment of forces about O is 0. Click Solution.
So in order to calculate the upward force of F, so the free body diagram, okay, the free body diagram should be drawn as shown, like this. According to the condition of the equilibrium of a rigid body, the total sum of the moment of the force about 0, about O is equal to 0. That means that this is the, okay, the point we refer. That means total down will be equal to total up. So we'll see how to solve it.
Taking moments about O, 20 times 2 plus 30 times 4 equals F times 8, which implies 40 plus 120 equals 8F, which implies F equals 160 over 8, which equals 20 kilonewton.
Okay, so easiest we said that. the torque in the direction of this is the reference point, right? So this will cause this system, this red color of the force of the load and the the weight of the load, the weight of the trailer will cause this system to rotate. This is our point, right? So that means that it will cause the system to rotate in clockwise direction. The red color will cause it to rotate. This will rotate in this direction. This one also in this direction. This means that I said that total of the torque will be the moment. Moment in clockwise direction will be equal to the moment of the blue color, which this will cause it in the anti-clockwise direction. So this one, I use the concept total, I solve by using the green color. Total torque for this one, clockwise, equal to the total torque of anti-clockwise. Okay, in clockwise direction will be 20 kilonewton. Here we use 20, yeah, 20 kilonewton times with the distance of R, plus with the 30 kilonewton times with distance of 30 will be 2 meter, that means 4 meter, equal to the anti-clockwise moment. Anti-clockwise moment, that will be F times with how much? The distance is at meter. So the F we get, it will be equal to 20, because this 20 is kilonewton, right? Kilonewton, right? So it's remain in kilonewton. Okay, so this is the concept we use. If the object is in equilibrium, total moment, okay, total moment in anti-clockwise direction will be equal to the total moment of the clockwise direction. Remember, if the object is in equilibrium, but this chapter, all of them are in equilibrium.
Summary. A rigid body is in equilibrium if the resultant force acting is zero and the algebraic sum of the moments of forces about any point is zero.
Okay, as a conclusion for today's lesson, the torque or moment of force is the effect of a force to rotate a body about an axis. The torque is given by the vector produced of the position vector of the point of action of the force relative to the axis and the force applied, where the vector of the torque is equal to the vector of the R times with the vector of the F. Easiest torque equal to RF. If they are not in the, if the F and R are not in the perpendicular direction, or they are not in 90 degree, so what we need to do, either use sin delta or cos delta to resolve the force, so that the force become 90 degree or perpendicular to the R, F perpendicular to the R. The equal and the opposite force not acting on the same point of a rigid body constitute a couple if they make any rotation motion. The resultant force produced by a couple is equal to 0, and the torque produced by a couple is equal to the product of one of the force and the perpendicular distance between the two forces. Okay, the force of the couple is to rotate a body but produce no translational motion. It's just produce the rotational motion but not produce a translational motion. The object is rotating, but the object still remain at a point. It's not translate. So that's all for today's lesson. Okay, and is there any question you wish to ask?